Open to page 10 of your Unit 2 course pack. So in the last Ed Puzzle video you watched, you learned about a barometer. A barometer measures air pressure. It was invented by Evangelista Torricelli. But what if we want to know the pressure of another gas? For example, a sample of oxygen gas or a sample of helium gas. A barometer will only measure air pressure, so we need a different instrument to measure the pressure of a different type of gas. So these instruments that you see here on the top of page 10 are called manometers. They will measure the pressure of any gas. So let's look at the manometer and number 1, letter A. So your gas sample is going to be in this glass bulb on the left. So you'd put whatever gas that you want to know the pressure of in that bulb. Then we have a U-shaped tube. On the other side of the manometer, you'll notice that that tube is open to the air. In the bottom of our U-shaped tube, we have mercury, or we once used mercury. We don't anymore. So this is what's happening in this manometer. Over here on the right, we have air particles. They're outside of the manometer, but because that side of the manometer is open to the air, those air particles can enter into the tube and actually collide with the surface of the mercury on that side of the manometer. When they collide with the surface of the mercury, they exert a force on the mercury. They push on the mercury. On the other side of our manometer, we have our gas sample, whatever gas that might be. Those particles can collide with the mercury on the other side of that U-shaped tube. So you have your gas particles pushing down on the mercury on that side. So it's this battle. It's like the opposite of a tug of war. Instead, it's a push of war. So you have two opposing gases pushing on the mercury, and you kind of have to decide who is stronger. Is the air stronger or is the gas stronger? So if you look at what has happened to the mercury in the bottom of that U-shaped tube, the gas particles are stronger. They're pushing down on the mercury more than the air particles are pushing down on the mercury. The purple gas particles are pushing down on the mercury so much that the mercury is going up higher on the other side. So in this particular manometer, the pressure of our gas is greater than the pressure of the air. Now, the next step is determine what exactly is the pressure of that gas. So one piece of information that we're given is the pressure of the room, or in other words, the air pressure. So we know that the air pressure in the room is 730 millimeters of mercury. So over there on the right side of our manometer, the air is exerting 730 millimeters of mercury of pressure on the mercury inside the manometer. We want to figure out what is the pressure of our purple gas on the left. So we have two measurements. We have a measurement for the height of the gas, the height of the mercury on the side of the manometer open to the gas, that's 84. And we have a measurement for the height of mercury open on the side of the manometer open to the air, that's 127. So we want to figure out what is the difference in the heights of the mercury. So how many millimeters different is the mercury on each side of that tube? So anytime we want to find a difference, that is subtraction. So we're going to take 127 minus 84. So we always want to subtract the smaller number from the bigger number. We're just trying to figure out how different are they. So we don't really want to mess with negative numbers. So 127 minus 84 is 43, and our units here are millimeters of mercury. So 43 millimeters of mercury, that is the difference between the pressure of my gas in purple and the pressure of the air in red. Now, the pressure of my room is 730 millimeters of mercury. And I know the pressure of my gas is greater because it was pushing down more. So if the pressure of my gas is 43 millimeters of mercury different and it's greater, that means I need to add 43 millimeters of mercury to the pressure of my room. And when I add those, get 773 millimeters of mercury. So the pressure of the gas in the bulb is 773 millimeters of mercury, which matches what I originally said, which was the pressure of the gas should be greater than the pressure of the air. The pressure of the air is 730. The pressure of my gas is 773. So I have not contradicted myself. So always go back and check your work and say, did I get an answer that matched what I said should happen? We said the pressure of the gas should be greater. Did we get an answer that matches that? And we did. Next, we're going to look at 1B. Same idea, it's a manometer. This manometer is actually flipped around. So in 1B, our air is actually over here on the left side. So we have the tube open to the air is able to enter the tube, and air particles are able to push down on the mercury over here on the left side of my tube. My gas particles are over here in the glass bulb. They're also able to push down on the mercury, but they're pushing down on the right side. So in this scenario, which particles are stronger? Which particles are pushing more? The air particles in red or the gas particles in blue? The answer is the air particles in red are pushing down more than our gas particles. And we know this because if you look at the mercury and what's happening in that U-shaped tube, the air particles are pushing down on the mercury so much more than the gas particles that the mercury has been pushed up the side of the gas. So now we have to do the math. We have to figure out what exactly is the pressure of that gas. We know the pressure of the gas is lower than the pressure of the room, but what exactly is it? So step 1 is to always find the difference between the height of the mercury on each side of the manometer. So on one side, we have 130 millimeters of mercury. On the other side, we have 26 millimeters of mercury. So to find the difference, we subtract. And again, we're just finding how different are they. So no negative numbers, so just always take big number minus small number. And when we subtract those, we should get 104 millimeters of mercury. So I know the pressure of my gas is 104 millimeters of mercury different from the pressure of my room. I know the pressure of my room is 730 millimeters of mercury. And I know the pressure of my room is greater than the pressure of my gas. We said that here. The pressure of the air is greater than the pressure of the gas. So 730 millimeters of mercury, that should be my bigger number. So this time, I don't want to add 104 to 730. Instead, I want an answer that is smaller than 730. So I want to subtract 104 millimeters of mercury. So when we subtract those, we get 626 millimeters of mercury for the pressure of the gas. And again, it's always a wise idea to kind of check your answer. Does it make sense with what you originally said should happen with the pressure of your gas? So if I go back to what I originally said, I said the pressure of the air should be greater than the pressure of the gas. Well, the pressure of the air is 730. My answer for the pressure of the gas is 626. So that makes sense. 730 is greater than 626. Now, I want you guys to finish the rest of these manometer problems. You're actually going to finish all of page 10, 11, and 12, and you'll submit the pages on Google Classroom when you're done. If you want a little bit of additional help, if you go back to page 9, there's an explanation of how to do these manometer calculations. So going back and reading that might help. You can obviously rewatch this video. Do the best you can on those problems, and we'll end up kind of checking our answers together next class when we come together again as a group.